The most common example of optical coating is anti-reflection coating. Most people know it from glasses. So it's a coating that removes the reflection that is normally on the surface of an optical object like a lens or a substrate. And it does it by doing the impedance matching between the different media where the speed of light is different. So the anti-reflection coating can be used on its own, but it's also part of most advanced filters. And actually the reason why you can have nearly full transmission even in a filter with a very advanced functioning and a lot of layers. The shortwave pass filter is a kind of filter that it's nearly impossible to do with anything else than an interference filter. And that's because it lets through the short wavelengths while blocking the long wavelengths. And the photon energy is high at short wavelengths while it's low at longer wavelengths. And it's simply not normal for materials transmitting in the visual and in the UV to let through high energetic photons while blocking those which have a low energy. Long wave pass filters are filters which reflect the short wavelengths and let through the long wavelengths. In the variable type, it can be used as an auto-sorting filter for array sensor in a compact monochromator system. The narrowband filter is a kind of filter that is used in a lot of applications. It can be used to limit the wavelength range that is present in the light from a light source. For instance, to fit the absorption excitation vector for a certain fluorochrome. It can also typically be used in front of detectors in systems which could be disturbing light, for instance sunlight, that could give you a lot of incorrect signal on the detector. There's also wideband bandpass filters. Those are mostly used in camera systems. You can use those to block the UV, which can cause stray light in the system, and you can use those to block the long wavelengths near infrared, which reduces the resolution in the camera system. You can also use a wideband pass filter to do the red, green, and blue filtering that is needed in a color camera. We can also do multiband pass filters, and the multiband pass filters are, for instance, used when the light sources are light emitting diodes and there's several of those, or if there's several lasers in the system. Smart filters is a special kind of filter where the same filter has different functions in different wavelength range. It can, for instance, work as a polarizing beam splitter in one range, as a mirror in another range, and as a narrowband filter in a third range, and so on. This kind of component is typically used in compact medical instruments. There's also the components where the light is incident at some oblique angle. They are normally called dichroics, a lot of those, at least those who are used to separate different wavelengths of light. So they can, for instance, be used in a fluorescence microscope to reflect the excitation light onto the object and to let through the emitted light from the fluorochrome. There's also beam splitting dichroics, beam splitters where there's intensity splitting, that half of the light goes in one direction and half of the light goes elsewhere. And there's polarizing beam splitters which can separate the S-polarized and the P-polarized light. And finally, there's beam combiners. Beam combiners are very much like the dichroics, but they are used to combine different signals. It could be the light from different light-emitting diodes or different lasers.